Good morning and good afternoon and evening to our global audience. Welcome to Innovations in Irrigation, the latest in our fall series of webinars focused on solutions for water and food security. I'm Peter McCormick, the Executive Director of the Doherty Water for Food Global Institute at the University of Nebraska. As we were unable to host our regular Water for Food Global Conference this fall, along with our partners, we moved a number of aspects of that conference online. This particular webinar has been organized with our partners from the Irrigation Innovation Consortium. The IIC is a three-year-old collaborative research effort funded by the Foundation for Food and Agriculture, FFAR, and the consortium partners represented here. The inception of the International Irrigation Consortium actually dates back to a workshop held at our 2017 conference here in Lincoln, Nebraska. So coming back to the roots to some extent. The IIC is a public-private partnership which is working to accelerate the development and adoption of sustainable water and energy efficient irrigation technologies and practices. We will hear more about the IIC and the partners shortly. I am excited to listen to these speakers, including our Director of Research, Christopher Neal. I want to thank you all for being here today. Your active participation in this event is an important step, not only for the IIC, but also for the just developing partnerships towards viable and sustainable solutions for water and food security more broadly. I would especially like to thank our webinar series sponsors, Valmont Industries. We are grateful for this support. It is my pleasure to introduce our moderator, Tim Martin, who recently assumed the role of the Executive Director of the Irrigation Innovation Consortium. Tim and I have actually known each other since we were graduate students way back in Fort Collins. I won't mention the number of decades. He, in fact, was one of the first people to introduce me to the potential of GIS and remote sensing, I think even before those terms were fully adopted. Since then, Tim has had a very successful career leading and managing collaborative water resources, agriculture, irrigation, and environmental programs in the United States and overseas, where occasionally our paths would cross. Tim, congratulations on your appointment, and over to you.
So, thank you, Peter. I appreciate that. That introduction, and you are correct. We have known each other for quite some time, and we've crossed paths, as you said, in many places of the world. Always, as I recall, when we would run across each other, it had to do with irrigation, with agriculture, with environment, and water resources management in many places in the U.S. and other locations in the world. So it's been a good relationship. As the new director of the IIC, I'm very fortunate to step into an organization with a firm foundation that's built on partnerships, that has committed organizations as partners like Doherty Water for Food. And we thank you today for hosting us and for introducing us to your really vast network. And as I was looking here at the chat and seeing the folks log on, as you said, they're from all over the world, and it's like a taxi meter in London. It's just going fast. So it's good to see. Today, I'm going to provide first an introduction of the IIC, a little bit more detail, and then we'll have our three IIC partners who will give some presentations. The three presentations are, I think you're going to find very interesting. I've seen previews of them. They're very interesting, very diverse. And these are partners of the IIC or working with us on this. A panel discussion will follow after the presentations, and we'll touch on many of the key questions and the drivers for this event. And we'll also, as I said, be looking at the questions that come in on the chat. So once again, please do that. So I'll now turn to my introduction to the Irrigation Innovation Consortium, which I refer as the IIC throughout this presentation. We are, as Peter McCormick introduced us, an alliance of industry partners and university researchers We're focused on irrigation. That is both landscape and agriculture irrigation. Our goals: accelerate development and adoption of water and energy efficient irrigation technologies, tools, and practices. We provide opportunities for joint collaboration and research, and we advance institution and cross-disciplinary understanding. Our key partners at the university level, we're headquartered or based here at Colorado State at Fort Collins, and our founding member universities are Fresno State, Texas A&M, Kansas State, and University of Nebraska. We have other university interests from other universities, and we are in a process of discussing with them about expanding this network. Talk a little bit about the funding. Our base funding, I think it's important that we recognize, first of all, we're able to do this in large part because of a very generous grant from the Foundation for Food and Agriculture Research. It's originally a 5-year grant. It's been extended to 6 years, largely because of events of this year. We're not quite halfway through our period of this initial base funding. And this funding of $5 million is being matched by non-federal funders that include universities, private and public sector. Again, the partners, I mentioned the universities, and we have a number of irrigation of industry partners, and this list is growing as we speak. Some of the key partners, founding partners, Irrigation Association, Aqua Engineering, Hunter, Toro, Jane, and many others that you see here on this display. I think this is, from what I can understand and from my research on this organization, it's quite unique. This is a partnership. Universities directly partnering with industry for purposes of irrigation and irrigation research and practice. I want to mention also, put in a pitch here, the IIC does fund research projects. We have a call that's out right now, came out about a month ago. The letters of intent are due on the 23rd of this month. There's still time. And so there's the website there, irrigationinnovation.org. I'll talk a little bit about what we're looking for here. The priority topic areas, this is for this call, but also it gives you an idea of, or it tells you what the IIC sees as a priority. Number one, energy, water efficiency, remote sensing, big data applications for improving irrigation, water management, system integration and management, and also acceleration of technology development and or adoption. So the three topics that we're going to talk about, presentations here shortly, each address one or more of these areas. You'll see it very clearly when we get into those presentations. The projects that we seek, the research that we seek, and the work that we do, it fosters collaboration among, as I said, industry, academic, NGOs, water districts, municipalities, and other partners. We catalyze high impact outcomes. We advance sustainability in the irrigation industry for, as I've mentioned, researchers, irrigation practitioners. We have a real strong focus on the practitioner, which again, you'll see from these presentations today. And we're particularly interested in pre-competitive research that involves pooled resources and data, results of which results from the research are open and accessible. Commercialization, however, is encouraged if it is building upon the results. So once we're done with projects and results, the open data, et cetera, industry are free and are in fact encouraged and facilitated to develop and develop proprietary applications, et cetera. So in summary, as I said, we're both...
Summary points are as follows. This is both landscape and agriculture irrigation oriented.
Sorry about that.
Further,
don't know where that came from. It's a summary. we know what the summary is. So we're pushing the conversation forward. That's our presentation today. So in this case, we are, these are the principles of this panel. And again, you'll see from the topics today, this is largely what we're focusing on: factors limiting technology adoption for both ag and irrigation, ag and landscape irrigation. We're interested in industry versus academic verification of standards. How to make technology solutions both friendly and used correctly. How can we facilitate research and industry partners together to best develop the next generation of effective irrigation tools and technologies? So the panel today, we have the three speakers. I'll introduce them very briefly. Christopher Neal, most of you know, Director of Research for Doherty Water for Food Global Institute. He'll be followed by Billy Tiller, who's the co-founder and CEO of the Growers Information Services Cooperative. Billy is also an irrigator, a farmer in Texas, and has a lot of ground up knowledge of the topics that he's discussing today. Charles Hillier, he's also part of the IICs on our executive committee. He's the director for the Center for Irrigation Technology, California State University, Fresno. So I want to welcome you again, and I want to thank you for attending this session. I want to move now right away to get to these presentations, which, as I say, I think you'll really enjoy, and the diversity and the range of those presentations are really important, and they're touching on some really important topics.
Thank you, Tim. What I'm going to discuss today is an example of one of the projects that the Irrigation Innovation Consortium has funded. And of course, it's mentioned that the original funding came from FFAR. This is about our Parallel 41 Flux network, right? And I'll describe this network, the concept, present the present status, give examples of the data being collected and distributed, and then how we plan to use it to ground truth global daily ET satellite product that we're developing. So the concept of this, we started this project about 5 years ago, and of course it's being accelerated with the funding through the Irrigation Innovation Consortium. The idea is to have a network of eddy covariance flux towers network together in producing evapotranspiration estimates in real time, right, of different agricultural vegetation and surfaces. And our goal is to use it for water productivity and agricultural water management in watersheds, and also provide real-time ET for irrigation water management to farmers and water managers, right? So this was the goal of the network, and of the funding that came through Irrigation Innovation Consortium with support by industry partners like the Climate Corporation and LICOR, and also USDA, a group of farmers, and NUBA Alliance, University of Nebraska, and the Upper Republican NRD is where we are today, right? Where we've been able to leverage this in-kind support and equipment donations and so forth to expand this network, okay? So the idea is to have this range of eddy covariant flux towers in this gradient of precipitation that I'll show in a minute, going from western Nebraska, eastern Colorado, all the way into Iowa, and where most of the agricultural is rain-fed, okay? And so we've been able to establish the original network you'll see here with the color of the pins, and we're adding now stations, additional stations in Nebraska, Kansas, Iowa, and Colorado, and eventually next year we'll add some of the stations that the Climate Corporation generously donated. Okay, and what I mentioned, the gradient of precipitation, here is what it looks like in Nebraska. You go from the semi-arid west to the rain-fed east. So this is a huge gradient, and of course, within the state of Nebraska, if you're going to produce crops like corn, you need to irrigate to a certain extent depending on where you lie on this gradient. So the details of this network, the eddy covariance flux towers are equipped with a new product from LICO, well, a relatively new, called the Smart Flux system. And what this is like a computer on board, it runs EddyPro, which is the community accepted software to correct and do all the necessary corrections on the eddy covariance data that you've got to do in the time series 10 hertz or 10 measurements per second. You've got to do a bunch of corrections to produce corrected energy balance fluxes and evapotranspiration in real time, right? So this allows you to do it on the tower in real time, and then through the Flex Suite software, everything is networked together, right? And so investigators can go into their tower and look at the data coming in real time and set up flags that say, oops, there's a problem. Okay, with the net radiation data, a bird pooped on it or something, and it's got to go and be cleaned, right? So it really helps on quality control and maintenance, right? Especially for towers that are isolated and hard to get to, right? So anyway, the idea is to get this data. It's publicly available through our Parallel 41 website. And right now we're monitoring rain-fed corn and soybeans, irrigated corn and soybean rotation in Nebraska, natural shortgrass prairie, and eventually turfgrass and sorghum in Kansas, I mean. So the Flux Suite software, the one that I mentioned, this is what the owners of the towers and the investigators look at, right, in real time, right? They can look at any particular tower, look at any particular instrument and see the data coming in real time. Here's an example of the ET data coming in, okay? But for the general public, right, we have developed then the Parallel 41 website. Here you can find the website, you can register, right, to have access. And this is what farmers or water managers in natural resource districts in Nebraska or water managers in Kansas and Colorado would go in to look at the real-time data. You could go and click on a tower, a picture of the tower comes up, okay? And then here's the tower in Grant, Nebraska. It's on a mobile platform, right? And it's wedged in between two center pivots. And this is sort of the windrows where the wind direction mostly comes. And we've got to pay attention to this because so we know from which corn planted center pivot the data is coming from, and make sure that that's clearly marked on the website. But you know, this is what the farmer could look at, right? And you could choose the units in millimeters and inches. The farmers in Nebraska would rather have inches because that's what they're used to. Researchers might want to see in millimeters because that's what they are used to. And you have graphs and real-time data coming in, precipitation, for example, the latent and sensible heat being generated by the towers. Here's the data for the whole season of 2019 from last year, okay? And then we also generate the actual evapotranspiration and the reference evapotranspiration from the local automated weather station. And from that, we can supply the crop coefficient. Now, this is the raw crop coefficient. Really, what we have to do is smooth this curve out. And what we're doing is, our plan is been sort of hindered by the pandemic shutdown, but is to get feedback from the farmers on what additional data they would like to see and how to make the website more user-friendly for them to download the data. So here's an example of the tower at Mead, Nebraska. Here's another one at Mead. So this is a rain-fed field. This is an irrigated field in continuous corn. And so the idea here is we're going to have this data in real time. And what we want to do with it is to ground truth a product that's being developed with other partners, right? In USDA and NASA, in the University of Maryland, and where we're producing using the VERS satellite. Here's an example of it in the Middle East and North Africa region. This is the land surface temperature from VERS. And we're running the Alexi model, which in the background runs the two-source energy balance model that treats canopy and soil separately. And we started in the Middle East and North Africa with this GLODET product because we got funding from the USAID to develop and run the product there. And it's run on 15-degree and 15-degree grid cells, as you see on this map, okay? So for the parallel 41, we would be running it here over the Central Plains, right? And this is an example of the product. Here's the annual ET for 2018, right? And this is at 375 meter pixels, right? Scale. So this would be a good product if you're going to do a water balance in a big basin or a watershed, or in the Nile Basin for that matter. And you can see the high ET in the Nile Delta over here, right, where there's a lot of irrigation. And here's an example of the tile in the Central Plains, where our parallel 41 network is, right? Here's an example for June 16th. And to make this useful, you know, we need to compare it to eddy covariance flux towers. Here, there's comparison of this 375 meter product with the 3 flux towers in Mead, Nebraska, which are on the parallel 41. They're also Ameriflex site towers. And you see here some of the preliminary comparisons at the 375 meter scale. Now, to make this useful for farmers and individual irrigated fields, Martha Anderson developed the DisAlexi model, which is the disaggregation of the Alexi. And this is being programmed up in Python, and it will be open source to be distributed for those who want to download the remote sensing product that's being run at the supercomputer here at Nebraska, and download to be used in places. So this will take the product on a daily basis at 375 meters and downscale it using Landsat imagery to 30 meters, right? So here you see center pivots on the Nile Delta in the fringes, and you can see here what they look like at 375 and what they look like at 30 meter scale. And this is a product that could be used then for irrigation water management on individual fields. So right now, we have 8 towers operational. We're going to install additional ones that have been tested this year and in the field, and are going to be put out next year along the gradient of precipitation. This is the Climate Corporation towers. And we hope to improve the web face interface to get feedback from farmers, add the additional towers from our partners, and develop method of anchoring the spatial remote sensing product that I just showed with the real-time data from these towers, right? And improve the accuracy of the remotely sensed product spatially. So when it gets downscaled, it's more accurate in the field level. And our goal is to expand the network with additional towers and partners, and hopefully get additional natural resource districts in Nebraska to buy in. Thank you for your attention, and I'll be available for questions at the end of the session.
Yeah, actually, Christopher, I think we're in this session, I think we'll throw out a question or two, brief ones to you specifically, and then we'll move to the next speaker, if that's okay with you.
Sure.
And I was just, and by the way, to the audience, we are seeing all the questions as they come in, and those are being collated, and we'll be looking at those at the end. So, Christopher, that's a very relevant and fascinating from a number of perspectives. I think the collaboration, from my view, the diversity of partners that you've put together there is phenomenal. And I'm just kind of curious to, aside from the technical for a moment, how do you manage to put together multiple U.S. agencies, multiple universities, local water districts, farmers, and industry all together into a project like this? You know, how do you collate such a group, and what's their incentive? Why do they want to stick with this diverse kind of crazy thing you've got going with all these collaborators? I think it's just amazing. Please.
Well, thank you, Tim, for that positive feedback. It's been a labor of, you build relationship with colleagues over time, right, and agencies, and that are doing good research, like the folks at NASA and USDA, and the folks in USDA-ARS that are running towers, right? So you work with them over time, and you develop the idea and together, and you put resources towards it, right? Obviously, the Water for Food Institute has been contributing resources towards these ideas from the outset, and we get the buy-in, and I think the mission, and I think why the buy-in is so interesting. I mean, it makes it interesting for the industry partners, for the government partners, and university partners, goes to our mission in Water for Food, and their mission as well is having impact on the ground, right? In other words, producing something that's going to make a difference to farmers and water users, that they can use a product, and we could show later that this has helped them manage water better, for example, or pump less from the aquifer, or some positive outcome. So I think that weaving this story together is what makes it compelling, and the buy-in from all these partners.
Yeah, well, I mean, that's part of it. And I think that academics, are often, I guess, criticized, or, there's an assumption that academics sit in their ivory tower and, cook up formula and write on chalkboards and don't really do much. So, and of course, we need that. We need fundamental basic research. But I think that's what I find unique about your organization, our organization, and actually all the folks that are here today, is the commitment to doing good, solid, basic research, but getting it to the field, getting it to the users, getting it to the practitioners, so that we can do our job to ultimately improve water management and improve irrigation management, and that's our ultimate mission. So I just commend you on that vision. And I'm going to take one more, maybe a short question here, which has to do with the marriage or the combination of the eddy covariance with the satellite image processing, which seem to me to be somewhat two separate tracks that are now coming together with this vision. And so I wanted to see where you think the future is in that sort of synergy or marriage, if you will, of two tracks. I mean, are you seeing the eddy covariance and all those, very detailed and precise real-time data? Is that a tool or an approach that you see to tune the remote sensing, and that over time you're going to have a much better remote sensing model so that you can, back off from the need for the real time, or is it have to do with the temporal or the spatial density of the amount of data that you need coming in. So is this a kind of calibration and get away thing, or is it a permanent marriage that they're going to be codependent? I guess that's my question.
Well, that's excellent question. At this point in time, it's a calibration and improve the accuracy of a spatial distributed product. Remember, the towers have a footprint that's in the field that they're in, right? So they're representing that ET or that crop in that microclimatic region, right? What remote sensing allows us to do is expand that into thousands of fields, right? But of course, remote sensing models have errors, and not every model is perfect. And so if we can improve that accuracy in real time by anchoring with these real-time measurements from the towers, that's a plus. Now, in the future, how well we could back off from this anchoring, right? And whether we're going to have to do this if we're going to expand globally, it remains to be seen through research. Remember, there's automated weather stations as well that come into the mix that are producing Penman-Monteith related reference CT that might be able to help in the process. So I think how in the future, how well we do spatially and how well that can be used by an app with a farmer, right? That they can go to find their field on the image, or automatically, if they sign up, it already takes them to their field, right? And because farmers don't have time to do more than 3 or 4 clicks and navigate, right? It's got to be user friendly, right? And how well that product is taken, and how far we can back off from eddy covariance flux towers, which are expensive piece of equipment, remains to be seen, right?
Yeah. Well, thank you very much. That's just fascinating. That's a segue to our next speaker. I think the farmers in the field and how they use technology, et cetera. So with that, let's transition over to Billy Tiller.
All right. It's a pleasure to be here. And I tell you what, it's I could sit and listen to Christopher for a long time, because this seems like things that could be applied and farmers use. And so that's always exciting when it's way past research. It can be field data, and he could be looking at it on his phone. So I commend you, Christopher. Keep up the work, and I'll be anxious to integrate this into some of our products. My name's Billy Tiller. Had a varied career, but I'm a farmer west of Lubbock, Texas. So I grow about 6,300 acres of grains and cotton. Normally about half of my ground or more being cotton. I'm in a very semi-arid region, but worked in technology for around 20 years. And in the last 10 years, myself, along with another group of farmers, stood up a data cooperative called Grower Information Services Cooperative. It's the power of sharing data within an umbrella of trust. So really what separates us at GISC is that we're farmer-owned, farmer-controlled, the things that you would think about when you think about any cooperative. So that's the unique piece of that. Oops, excuse me, I'm gonna back up. I was trying to move one of those screens that was part of, there we go. But, we're in a unique position, I think, to be in a position to trust work with growers. So as I think about really what has happened to us, how we've worked since really around 2012, when we came about, we are one proven path to adoption. One of the things in ag technology that is really difficult is that farmers struggle really to understand why I need to adopt a certain program, path, or ag technology. And many times those that build that ag technology haven't talked to very many farmers. And I heard Christopher use the word, things need to be simple. They need to be easy to use, 2 or 3 clicks. He's evidently worked directly with farmers, because that's one of the things we do when we build applications. So we have a software team. I have a great CTO that's very versed in cloud technology, but the proven path to adoption really involves trust. And that's one reason I wanted to throw up a slide around something called Ag Data Transparent. If you're not familiar with that, you ought to go look at this website. It's an effort within the industry to help farmers understand what's going on with their data. So picture this, farmer can go look at this website, and if someone's become certified in Ag Data Transparent, there's just a series of questions that are answered by the ag technology provider. And there are many in the industry, big companies, John Deere, for instance, has as the transparent seal. They've answered the questions. A farmer can realize what's going on with his data. I'd always say that progress moves at the speed of trust. We wonder what's happened within agriculture, and I think that's one of the difficulties that has went on, is that there is a lack of trust. I want to talk about one particular project. We work across the United States, but we actually like to work in regional areas with specific groups that have specific needs around data that needs to be integrated where a farmer can get the most out of his data. And one particular project we have is in the Twin Platte Natural Resource District in Nebraska. Now, how does a Texan end up in Nebraska? Well, I have a board member, Mr. Rourke Paulman, that is actually brought this project to me, brought me and helped me understand the need of Twin Platte in Nebraska. I'm going to tell you very quickly, the issue facing the growers there is that they're in the second increment of an integrated management plan. And that plan actually calls for them in the next 10 years to actually find 25,000 acre feet of water and return it to the stream flows. Now, as we begin to look at the data that was used in the modeling to understand what a farmer needed to use in his irrigation, it became aware pretty quickly that the data was very, it was a little bit ancient. It's back from the late 90s. Irrigation's changed immensely. Farmers are way more efficient today than they were then. But the only way to prove that is really think about what can we do? Let's have a data collection initiative. And so instead of Twin Platte, and I have to give them kudos for really trying to work with all stakeholders, not creating a war around water, but really calling on the farmers and saying, hey, if you want to have your data understood better, then you certainly need to be part of a data collection initiative. So our part in that was twofold. GIC, which is a data co-op, we're owned by the farmers, so we actually try to approach them from a position of trust. And we're normally able to do that because we will work very diligently to make sure that the data that's collected, aggregated, utilized, is actually utilized in the most accurate ways. Now, that means we're for the farmer, but we're more for accurate data. I always tell farmers, wouldn't you want the decision to be based off truth or really old facts? So if it's based off truth and it's not what I want, at least I know I'm not being harmed by bad data. So along that line, this is really, this is really what we built when I think about the way we built the Twin Platte program: connect, collect, verify, and present. And so we connected fields and well data that were part of Twin Platte. We signed up growers and they checked out from within our platform the fields that actually were owned by them. But here was the unique piece. We were trying to figure out a way, how can we go out and understand irrigation data without putting a water meter on 3,200 wells? And it was really just the sheer cost of the project if we went that direction. So we realized that about 80% of the wells used electricity, and all but just really one of the providers there had already installed electric smart meters. These meters actually push data to the electric provider in 15-minute increments of the amount of electricity used. And the beauty of that is we actually get a clock. So we're not so much converting power back to water use as we are converting time back to water use. So we sniff that data continually from all the power providers, and we're looking for an instance where an irrigation event would actually begin. And when irrigation event begins, then we start the clock. And so what we have to do is we have to have great pump rates. And we send well drillers out to get those pump rates for us. So that puts then a visualization in the hand of the grower. The other key piece of this is that it's a huge collaborative effort. Now, how would we be able to create such an effort? Really swallowing our pride, realizing that no one group could create all these things on their own. So we use Amazon Web Services in the cloud. That's where GIC actually stores the data. We get the data in the cloud ready to share. We had to hook up with, of course, Twin Platte and all the data they had. They had a hydrology group called Olson. We connected with Olson, Page Wireless. Now, why would we need IoT devices beyond the electric? I said about 80% were electric. What are we going to do with the other 20%? So Page Wireless has built a LoRaWAN network in the area, and across the state of Nebraska, they're working diligently to build that out. And so we have actually what we call continuity devices or pump monitors on diesel wells, for instance. So we're able to now bring that data in. Sitka has a software called GeoOptics. They work with Olson and work with us, and they actually sort of translate and actually organize the data off the page devices. And of course, we have the power companies, we have the farmers, we have flow meter validation. So right now, every day I'm working through flow meters that were out on actual wells where we can actually audit those wells. So we have several wells that have flow meter data along with electric data, and we're doing the auditing there. And that's really what came into the project that was the IIC project. And the beauty of that is it was a project that was really to help us validate. So we wanted to present a visual record to farmers. We wanted to verify the results. We wanted to validate the accuracy. We wanted to be granular and bold and engage the farmer in that way. So how could we do it? GIC is a dot connector. That would be our greatest thing we do. We bring together the groups to actually work together. NUBA, who's a Nebraska Water Balance Alliance, worked closely with us in this grant that we have through the IIC, and working with cooperating farmers, because they're going to help us actually analyze the accuracy of these power records versus actually what is actually being pumped. And the beauty of that is we'll then take that data and we will refine our algorithms at GIC so that we get better and better data, because we want to highly approximate the actual use of water. Quickly, the last things I have here are just talking about the goal of the project with Twin Plat. It was to actually bring a knowledge of the time and water used to the irrigators and the watershed managers. And then, of course, this project that we have going on through with our partner NUBA and also other partners. We have Del McDermott is the primary investigator out of NUBA, Jim Snyder out of Olson. Of course, there's myself out in the cotton field. But it's the idea of bringing together, analyzing, and actually trying to bring more accuracy into our model, especially with a water table that might have up and down movement. Of course it will, right? Most water tables, as you get away from the stream flow of the river, begins to be more fluctuating. We want to understand, can we really monitor that with electrical data? The last slide there is of one of my board members, Dickie Brown. He said, I needed a strategy to understand how data could benefit my farm. GIC has given me a path of independence concerning data. Thank you. I'll stop sharing here and I'll turn it over to Tim for any questions.
Yeah, so thank you very much, Billy. That meshes so well with the previous discussion, and focused in the same region of the world, and now you're right on the ground with the farmers and the irrigators. A couple of kind of similar questions. I think that's my theme of the day, really has to do with cooperation, and that's what the technology here is just really fascinating, and to me it's how these words that I wrote down here, I keep hearing: collaboration, consortiums, cooperation, it's all the C's. So, my question again is, or similarly, is looking at the farmer on the ground. What is his drive or incentive? I think you kind of answered this, but maybe directly. What's his incentive to be open with his records, his data? Why wouldn't he sort of keep that to himself and just, not make that publicly known and just kind of do his own thing?
Well, you've hit it. Now we could interview 1,000 ag tech companies that have run through this industry in the last 10 years. And the biggest issue becomes, why would the farmer do this? Why would he be engaged? And if you don't have a farm background and you don't have something on the ground, that's a hard question to answer. I always tell this quick story about pain and gain. If there is no gain for me, if you're not going to get me a premium, I don't know why I would share my data. If it's not going to bring me a return at the farm, why would I share my data? On the other side, is there pain? Do I have the risk that if I don't get collaborative, if I don't begin to drive the bus and I'll get out in front of the problem, is there pain involved with that? In the case of Twin Plat, there could be. And I use that with those farmers because I want them to be realists. We have to be driving the bus on data. We need the best data collected so that they get the best answer as they go forward. So ROI, that's the key. And how do you bring all those collaborators together? I want to say this in benefit to every party that's helped us in Nebraska. They've swallowed their pride. They've lost the idea that they're going to be the only siloed platform. That has to happen in the industry. We have to integrate. We have to work together. If we want to get real answers, I mean, farmers are tired of opening up platforms and knowing I'm going to look at this here. I'm going to get into another platform. I'm going to get my password username over there. We have to have some interoperability between these platforms. And that goes for the big guys and the little guys. I don't care who you are. Let's figure out how to do this for the farmer.
I think there'll be there's many questions along this line that we'll get over to. That's just very interesting. One 10-second question. What's the rate of adoption? What's the user rate here?
It's crazy. We've had decent adoption in projects. We're literally a tad over 50% as of today. We started this in September of 2019. We haven't been back into Nebraska in front of farmers since March, and yet they signed up. Why? The very reasons I gave you. This proves you can engage. It's a 320,000 acre project, and we're at 50.3% of that. I'm amazed at the farmers. I just applaud them. I applaud the NRD for taking the initiative and being progressive, and I applaud those farmers for stepping up to the plate.
Well, it looks like they also have a cheerleader helping them sign up. So that's a good thing.
Definitely cheer them on. Thank you.
Well, thank you for that. And let's now turn to our third speaker, the final speaker. And then following that, again, we'll get to the questions. So I'll turn it over now to Dr. Charles Hillier from California State, Fresno. Please take it away, Charles.
So I'm Charles Hillier. Thank you for inviting me here today. I'm going to be telling you a little bit about the Center for Irrigation Technology. And then I'm also going to tell you about two of the IIC projects that we're running through Fresno State. So CIT was established 40 years ago. This is actually our 40th anniversary. We got our start doing testing irrigation components. That is one of our three focus areas. And I'm going to show you some slides about the testing facilities that we have. We also have a very active applied research program, and I'm going to tell you a little bit about those resources. But most of what I'm going to talk about is our technology incubator and accelerator program called the WET Center. In fact, the building that you saw in the first slide is the WET Center. So CIT actually got its start testing sprinklers. We have expanded that since to test almost all of the hydraulic components that are part of an irrigation system. So we also are active with the standards bodies. So we develop testing protocols, or we're involved with the groups that develop those protocols. We also have testing services to analyze product failures. So we provide testing services to local farms when they've got technology components that aren't working as expected. Our laboratory has multiple parts. Our star of the show is our hydraulics laboratory. This was built back in the mid-2000s, mid-2000s. And we can test valves, pumps, valve closing times. We have a emitter clogging test. We have about 21 standard tests that we can do. We also have a sprinkler testing laboratory. This was actually the first building that was part of CIT. It's a large enclosed building, and we use it to measure the distribution patterns of irrigation sprinklers. Over the years, we've also developed a software package that helps people analyze the distribution patterns of irrigation sprinklers. We also have a very active research program, and we are very lucky to be part of the Fresno State Farm. This is a 1,000-acre farm that is right in the middle of Metro Fresno. This farm represents a sort of a microcosm of the Central Valley of California. So vineyards, almonds, citrus, vegetables, row crops, field crops. We've also got a variety of irrigation system types, so drip and micro sprinkler. We've got a pivot here, and we also do a little bit of surface irrigation as well. CIT maintains its own set of research plots within the farm. This is where we do all of our applied research. We pack as much as we possibly can into these 6 acres. We've got some dedicated turf plots. We do a lot of vegetable crops. We also do a little bit of surface irrigation as well as drip and sprinkler irrigation. Now I'm going to transition over to the wet center, and I'm going to show you a video. This video combines both some of the business incubator as well as one of the first IIC projects that I'm going to talk about.
The mission of the Wet Center is to help water, energy, and agricultural technology ventures commercialize their technology and develop business in California. We do that by using our Blue Tech Valley Innovation Cluster, which is funded by the California Energy Commission and part of a statewide system to help clean technologies be successful in California. And also through our Valley Ventures Accelerator, where we take cohorts of these ventures and accelerate them towards success. It was wonderful connecting with Nitricity and Nico Pinkowski, one of the 4 co-founders. They come with great street credibility, if you will. We have 4 doctoral candidates from Stanford, and they received funding from Stanford's Tomcat Fund to help introduce their technology.
Josh and I, as Brian said, have been working on nitrogen reduction or nitrogen activation for a very long time, about 5 years. It was also my PhD. And yeah, the opportunity came along to sort of bring that into the real world, and that's what we're doing here.
Super excited about this company. I think that we're going to fix the way we fix nitrogen today. It's going to be done in a more sustainable way, and we're going to bring it all around the world.
I'm super excited about this project. I'd be very happy to spend my whole career working on this. I think it's a really important problem, and I think we're working on a potentially impactful solution.
Talking to them and understanding what their technology is about and vetting that, we went through a process and they talked with folks here, subject matter experts, who looked at Nitricity's technology of what is pretty remarkable. It's taking air, water, and solar energy and creating fertilizer for farmers.
Production of fertilizer today is done in immense facilities, and it requires natural gas or coal for hydrogen source. It actually uses 5% of global natural gas in the production of nitrogen fertilizer. So in trying to get a lot of nitrogen into the soil, we are emitting a lot of carbon into the sky.
Nitricity was introduced to me at a technology and innovation evaluation meeting we had with them. The evaluators and I looked at their proposal and we were all quite excited. It was a potential game changer in agriculture.
Nitricity is a fertilizer company. Very simple. We make fertilizer using air, water, and electricity. It looks just like a solar array. It's a set of solar panels, but under this set of solar panels there's a box, and that box breathes air and takes some water. And using the electricity from the solar panels will make nitrogen fertilizer at the irrigation head where it's needed. Nitrogen fertilizer can have a profound impact if decarbonized. It accounts for a substantial amount of global CO2 emissions today.
It could be a tremendous way to reduce the energy requirements for our fertilizer production.
We have an idea that's impactful. We want to stand this up as a business on its own. And to do that, some of the most important things are contacts and funding. And Blue Tech Valley was this intermediate stage that we could reach out to. Yeah, we've used their resources a lot. It's been fantastic.
They've really caught the attention of our institution here, and we're so happy to be able to work with them and pleased that they chose us to partner with them in the research and development of their product.
And with the Fresno State Wet Center, we touch a number of ventures every year, over 100 ventures per year that we'll review. And they're able to take advantage of our programs and try to succeed. And we've had a number of successes.
Yeah, Blue Tech Valley has been great. And the experience we've had with them is great. Every time we go down to Fresno and interact with them, so many positive things happen for our company.
So that video gives you some idea of what the Wet Center does. You saw quite a bit about the Blue Tech Valley program that's funded by the California Energy Commission. And Nitricity's field research and prototyping that they did was actually funded through the IIC. So this is kind of an example of what the Business Incubator and Accelerator program does, as well as how we can establish connections with the IIC to help these startup companies with innovative ideas take their product to the next level and build it towards commercialization. So the next thing that I want to talk about is the second project that we worked on with the IIC. This was led by Dr. Keamine Bang. You can see him right there on the right. There's Keamine. And the industry partner here was Perrigo Welding. This is a company in California, and they had an idea for a low pressure filtration system. The idea with this was to build a system that addressed some of the pressure requirements that are typical with sand media filters. Sand media filters are very common. They work quite well. They require very little maintenance, but they do have a significant pressure requirement. And Perrigo had an idea to build a different design for a filter that used much lower pressure. This was appealing because in many drip tape systems operate at a much lower pressure than what's required to operate a sand media filter. So if they can build a filter design that uses pressure that's more in the range of what drip systems require, you can actually save a lot of energy and hence save a lot of cost for the filtration. So Perrigo and Dr. Bang and the team in the CIT Hydraulics Lab brought in their prototype design, and they used the testing facilities in the hydraulics lab to test both the head loss characteristics, the flow characteristics, as well as the filtration efficiency. So they did some emitter plugging or some clogging tests on the filters. They've got some pretty interesting results. In addition to using the IIC support to help take this product into a more commercially viable form by assessing its performance and quantifying its performance. They also learned that there are some interesting things about this system when the clogging happens. And this actually helped the industry partner refine their design and make it handle where the clogging media gets caught up in the system. So it actually helped them improve their product or improve their system through the IIC research. So that's it for me. And I know we're getting pressed for time. So I am going to hand the baton back to Tim.
Okay, thank you, Charles. In keeping with our protocol here, I think I'll ask a couple of questions and then we'll be done with that, and we'll go to the questions from our participants. So as with the other ones, Charles, I'm struck by, again, the collaboration, and I think in Colorado we have some of these incubators and accelerators, et cetera, and I think they pop up, and they're, especially you find them in university towns. But you know, I'm curious about the collaboration or the work with the California Energy Commission and this accelerator in Fresno and the university, and sort of how does that come together? Who funds that? That's the first question, and I'm especially kind of thinking maybe some of our international partners might be especially interested in that model, because we're starting to see that pop up in some other parts of the world. But give us the high points of what's really appealing and successful about that.
Well, the business incubator, you pointed out an interesting correlation that these incubators tend to be at universities. And a lot of the incubators tend to help researchers who've come up with a really great idea and turn it into a product, a great product, right? That's the process of commercialization. But researchers don't know a lot about marketing or business strategy or employment laws, budgeting, advertising. These are all the kind of things that a business accelerator and incubator can help them learn. And the Nitricity guys are a great example of that. You have 4 PhD students. And so a lot of the time that they spend in our accelerator program was learning about marketing, how to price products, how to get venture funding? What are the different kinds of venture funding? So it's the kinds of things that somebody who has a strong sort of inventor background, but not a strong business background.
Right.
And so Nitricity is kind of one of our poster child examples of how that can be successful. But in order for them to do that commercialization process, they need support to do the prototyping. You know, they had done the science. When they came to us, it was very clear they had the science figured out, but they hadn't done the engineering, right? They knew that the idea was sound, but they didn't know if the product was really going to be viable. And that's where the IIC really made this relationship work, because the IIC provided the funding they needed to do the prototyping, to develop that product, or to develop that technology into something that could be viable. You also asked about the CEC. The California Energy Commission has been funding projects at CIT for years. The WET Center was actually funded by the California Energy Commission. It's something that the people who buy electricity pay for. They pay a very small amount that gets pulled together, and then the CEC uses that to fund various initiatives, one of which being research and business acceleration. So the companies that go through the business incubator have to have a presence in California, and they have to have some impact on energy, right? So energy and water are intimately related. We all know that. The CEC is interested in funding technologies that are going to improve energy efficiency, and we focus on the ones that are going to improve energy and water efficiency.
Good. Well, that's also, as I described earlier, that's the foundation of or the principles of the IIC is both energy and water efficiencies. And I also would point out, just in thinking about this, the incubator concept and the collaboration, et cetera. I mean, that's one of not necessarily as an alternative to incubators and accelerators, but industry has, they can serve in that function as well. And that's what we're finding with our industry partners, that, their job for the most part is business. So they understand business, they understand real business, and they are, on the ground developing products and getting them out into the marketplace. So that's a great, model as well. I think there's room in there. In fact, you just demonstrated it, that we have room at many places for different actors in this collaboration idea. But not to forget the industry with their, R&D capabilities and so forth. That gives us a real unique insight. So I appreciate that. One last question on nitricity. Just I see a question or two about this as well. Where do they and you see them going? They've got a great idea. Do you see it potentially as being economically feasible? And is there competition? Is there competition for that? I'll give the two questions.
Well, when they came to us, their original plan was to build sustainable nitrogen fertilizers that would be sold in specialty garden stores. And during their presentation, I sort of challenged them a little bit and asked, do you guys realize that you're talking about a $40 billion industry in agriculture? They didn't know. They come from a totally different world. They've since sort of transitioned, and their focus is very, very much on sustainable production, right?
Sure.
They've got a technology that, if the engineering works out and the economics work out, it really could have a profound impact on the sustainability of agriculture, because now you won't be buying nitrogen anymore. You'll be making it on site using air, water, and solar panels, right?
Yeah.
So that has the potential to help growers go to being carbon negative, right? And having a way for them to now have another source of revenue by selling their carbon credits. That's where they want to go. They've still got that, sustainable production mindset. But now they're thinking big, right? Now they're thinking, oh, we can address that $40 billion market, not that $5 million market.
Yeah, I mean, Phil, it sounds like a kind of a classic, research to development, research, R&D, and to the user type of situation there. So I think we'll all be watching that with great interest over the next little bit to see how that works out. But certainly the ideas are just very stimulating, really fascinating. So we'll turn to, and if the speakers kind of sit tight here and have your mute button ready, because I'm going to sort of look at some of what's come in here and, stage up a couple of questions here that are coming in from our audience. I think the first one perhaps for Stephen, for Christopher. It goes like this, Christopher. NOAA already has the FRET product, F-R-E-T. What's the benefit of the Flux network versus the FRET product? And how can, let's start, I'll pair that with one other question. How can the farmers use the data on a daily basis? So FRET, and how can farmers use it?
Okay, well, I have to say that I'm not very familiar with the FRET product, so
okay.
I'd rather not comment on that, but I'm going to certainly look into it now. As far as the farmers, I mean, a lot of farmer, the challenge is the behavior, right? And different farmers have ways of doing things in their fields, and Billy understands that very well, right? Some farmers want to adopt technology, but they would rather wait and see the benefits before adopting it. Other farmers are business as usual and do irrigation the way their parents did or their grandparents did and continue doing it that way. And so we've got to show that any product, whether it's a technology or an ET product like the one I was discussing, is going to be useful for them, and it's easy to use and helps them manage water better, right? So that's going to be the challenge. And in the case of Nebraska, and I think it would be easier, maybe possible to emulate. In Nebraska, we have the natural resource districts that have a very strong convening power, right, of engaging the farmers within their district. So we hope, working with the districts and with the Nebraska Extension, to be able to, present the product in a simple way, have webinars and tutorials so they can try it out quickly and learn how to use it, and then continuously help them use it so that they can see the benefit, right? Which is, as far as we're concerned, if they can produce the same amount of yield or very similar, but lower the cost of production because they're going to pump less because they've saved 1 or 2 irrigation cycles and so forth. That's the sweet spot we've got to go through and show to them that that's possible, and have that conversation that happens in February in the local coffee shop, right? Instead of, well, I got 220 bushels last year, right? And I got 3, the conversation should be, I got a better money in my pocket because I reduced the cost of production, right? And as it was alluded to by this recent presentation with Charles, in the future, carbon credits is going to be part of the equation as well, right? All this is going to go into lowering the cost of production and finding the sweet spot, which might not be maximum yield. Okay, so that's what we got to work towards.
Just to add to what Christopher said, regarding the FRET product specifically, I've used that quite a bit over the years. Christopher described how the Parallel 41 network provides in situ validation of these different remote sensing products. Same thing applies to FRET. FRET's a simulated reference ET. It's forecast, right? And so the Parallel 41 network provides yet another valuable in situ validation and test of the FRET product.
Right. Yeah, I think I'm familiar with that that development. I think it's done largely from Boulder here in Colorado at NOAA there. So, well, that, and this is a dialogue, by the way. So, Billy, if you have anything on top of that, otherwise, I've got a question or two queued up for you here. So, and I see you got the clock in the background there, so we all know where we stand. That's good to know. So, Billy, here's a question that really is kind of related to what we were talking about before, but it's got a little twist to it. I'm interested to pose this to you. One great challenge has always been the balance between data sharing and associated regulatory implications. Now, I think what that means is, especially with government, and let me add just a little thing here. Having worked in many different parts of the world, the U.S. is probably the most open data country I think, the most open data country in the world. Many places in the world, it is absolutely not that way. It's very difficult sometimes to access data, and I'm not talking necessarily about individual farmer data, but even global data or regional data or data that's developed by government agencies. In some cases, it's supposed to be in the public domain, but it's really difficult to get to. So I think we're curious here about how you see that balance, and also, how does that work with you on the ground? And I think this again relates to incentivizing folks to work with you and with one another.
Yeah, so I can jump right in on that because here I'll reverse the question and then I'll answer it. Would if you there has to be a balance, but if you don't share data, you might be regulated with inaccurate data. That to me has greater implications than being regulated with accurate data. Because let's use an example in the Twin Platte Natural Resource District. Let's say that they had inaccurate data and they were regulating along those lines. In 5 to 7 years from now, remote sensing is much better, and we all of a sudden are saying, oh, they weren't using as much water as we thought. Oh my goodness, they've been 3 or 4 inches of water we didn't let them use every year, and we were wrong. To me, that has great implications to the value of the real estate, to the income to the farmers, to what suppliers sold to them. That's the greater risk. I can handle the truth. I may not like it, but I can handle the truth. And so the other thing becomes, farmers are also concerned, what about at an individual level? Let me use an example. In Twin Platte, we gather individual farmer data. And in that data, we give him some privacy. And we give him complete privacy, complete control. We have him give us a explicit check mark. We can share that with Twin Platte. One farmer, 75 years old, came into a meeting. I was speaking, and he walked up to me after it was over, and he said, "You're putting a gun to my head. You're gonna blow our brains out here. The state's gonna take this data and begin to that we're gonna lose our resource districts. They're gonna have my data, and they're gonna begin to control who can irrigate and who can't." And I understand that there are better irrigators and worse irrigators, but I'm gonna compliment the Nebraska Department of Natural Resources. And this is why you have to listen to every grower. You should always be transparent, hear their question. I was in a meeting with NRD and I raised the question. I said, can we build this project where you see aggregate data from a region and you work from that level, while Twin Platte at a local level, they do see the individual data. And they said, good Lord, Billy, we got so much data. We couldn't granularly work with all that data. And we said, we'll wreck your project if we don't agree to that. I said, absolutely. Farmers are not going to join for fear of control. They're okay with, the NRDs are a form of self-regulation, a good form, because they have a whole group of stakeholders. Farmers are just one of them. So I'll stop there, but I think you get the point. We have to have good data. Farmers need to be in the driver's seat. Quit riding the bus. These are terms I use all the time. And get up there and get control. If you're in the lead, That doesn't mean you can manipulate the data, but let's make sure all the data is on the table.
Yeah, well, these are very, very good examples of to the question that we were addressing there about the balance. And I think what you're saying very clearly is, the proof is in the betterment of irrigation practices, and and that's where this leads. So, and I think to our, some of our colleagues, especially that are faced with some of these regulatory inhibitions or constraints, is finding examples not only from internationally and from other locations, but within your own region, where you can show that use of data and opening up is an advantage to the farmers, to society, et cetera. And this has been, an issue and a challenge. But, I think what I'm seeing, I think they're making progress, we're making progress, and these examples certainly help to help with that. Let's see, there's a specific question, Billy, and then we'll move to something else. So what do you think, and you kind of answered this, but just maybe specifically, what do you think led to the degree of collaboration between all the parties in the Twin Platte Water Data Program? So what brought them all together at that level in the Twin Platte program?
It was actually an amazing piece of work. No one person can take credit for this. It was the first time I've ever been in a project where everyone agreed. The greater good only came about when we all agreed to work together, to each have our own. Look, we had our pocket of expertise. We shared data across platform. I've never had it happen before. And I'll tell you how we got it done. We asked for it. Every meeting we had, we all agreed, okay, who's doing what? I'm building the grower tool. I'm not going out and collecting data off the page devices. Sitka did that for Olson. They passed it to us. We've all created a niche where we are experts. Normally what happens in all the projects over the last decade, we'd begin work in some company or some group that had a lot of resources, usually begin to sort of take the lead on everything. And before long, the collaboration's gone, the adoption falls. I just encourage everyone, when you're dealing with academia, when you're dealing with researchers, when you're dealing with these companies, we should work together to try to help the farmer. And along those lines, something Christopher said, talking about, he was literally leading up to, it's not profit. I mean, it's not yield, it's profit. And he is so right. We've got to focus on profit. And in that vein, one of the tools we're going to build, we'll begin to work on next year, is a benchmarking tool that takes into account the rainfall at every field, the best we can, ET. And so that's what I'm really wanting to look at what Christopher's doing. And I think that way farmers can see their own score. How am I doing compared to other growers in the water use? That's the only way we'll ever change this picture, is to let them see how they're scoring.
Good. Well, I appreciate that. We're getting down here to the last couple of minutes. I've got a couple of questions here. I'll just kind of summarize and say, with this screenshot here that's up, you have the contacts for the different presenters. If there are follow-up questions, I think I'm safe in saying, please feel free to reach out to our presenters.
Absolutely.
And in the case of the IIC, there's a question here: how do we become members? And please reach out to me, and we can have a dialogue about that. We are expanding. I think, well, we have 2 minutes here. So I have one sort of summary question here, very brief time to answer it. But, it says here, this in relating to, for example, soil moisture probes, which we're not talking about exactly, but it's a good example. The adoption in the US for soil moisture probes is like 10%, maybe 20 at the most. And are there upcoming technologies that we think that will be scalable and deployable and cost effective that will help increase the adoption rates? So, I mean, that's not a 2-minute question, I know, but maybe I'll point that to Christopher and say, that question now, and from your perspective, the remote sensing aspect of what you're dealing with, where do you see that going?
I think that if we can develop a good product and make it easy to use and show and teach farmers how to use it, then I think it will be adopted eventually. If it's useful, that's where I see this going. And
good enough. Well, and I think also, the remote sensing side that, certainly the provision of data from satellite imagery, et cetera, is very well established. And it's through these type of applications that we encourage, our government agencies and private sector to keep launching satellites and keep sending us data, because we're putting it to use. So I appreciate that. I think we're 1 minute here from closing. So I want to, I had a few summary kinds of comments, but I think we've made them here through the questions. So I think what I'll do here is just really turn this to an appreciation to our hosts, especially the folks at Doherty Water for Food. And I want to just really extend our appreciation to all of you and especially to the folks that contributed to. I had a list here of names. I'm sorry. It's not going to turn up, but you know who you are. Francis, especially Molly, and on our side, Amy and Susie. And thanks to our panelists, it was really an excellent presentation. The diversity is what really jazzes me up to have such a great different number of perspectives. The questions were great from the audience. Please send some more. Please contact us at these addresses. And thanks once again to our host, Peter, for introducing us and for allowing us to use to work with your network, which is fabulous.